NASA needs humans on the moon fast. But there's a problem nobody's talking about. SpaceX has been burning years trying to perfect one thing: reusable heat shields, 18,000 tiles per Starship, each one installed by hand. Each flight requires inspection, repairs, delays. What if that's the wrong approach entirely? SpaceX just revealed a variant that throws out the rulebook. No heat shield, no tiles, no flaps, just raw capability. Could this stripped-down Starship beat China to the moon? Here's what SpaceX discovered. The path to the moon doesn't require perfection. It requires speed. And right now, the reusable heat shield is the bottleneck strangling everything. Elon Musk hasn't been shy about this. He's called the reusable heat shield development a nightmare. SpaceX tried stainless steel tiles during Flight 10. The result? The entire vehicle returned looking like a rusted-out car abandoned in a junkyard. Orange corrosion everywhere. The material failed spectacularly. They still haven't publicly revealed what alternative they're testing. Why does this single component matter so much? Because getting to the moon requires 3 distinct Starship variants working in perfect harmony. The tanker delivers propellant. The depot stores it in orbit. The HLS lands astronauts on lunar soil. Every single piece depends on the tanker flying repeatedly without failure. But here's where the math gets brutal. A reusable tanker needs to survive re-entry at 17,000 miles per hour. Those 18,000 heat shield tiles aren't decorative. Each one protects against temperatures exceeding 2,500 degrees Fahrenheit. After every flight, technicians inspect every tile. Damaged tiles get replaced. The process takes weeks. Then the vehicle moves to the mega bay for refurbishment. More inspections, more repairs. Finally, it rolls back to the launch pad for refueling. Time bleeds away at every step, and time is the silent killer in orbit. The depot sits in space holding cryogenic propellant at negative 297 degrees Fahrenheit. Physics doesn't care about your schedule. Propellant boils off continuously. The longer refueling takes, the more fuel evaporates into space. Every delay costs tons of propellant. How much propellant are we actually talking about? Artemis 3 requires the HLS to carry astronauts from lunar orbit down to the surface and back. That single mission needs roughly 1,500 tons of propellant waiting in the depot. Current projections estimate 8 to 12 tanker flights to deliver that much fuel, but those numbers assume everything works perfectly. One failure pushes the timeline back months. Suddenly you're looking at 15 flights, 15 separate launch windows, 15 opportunities for something to go wrong. Each standard reusable tanker transfers about 175 tons per flight. The engineering is actually impressive. The vehicle launches with maximum propellant, reaches orbit, then carefully transfers fuel to the depot through specialized connections. But all that reusable hardware comes at a cost. The tanker carries flaps for atmospheric control, heat shield tiles covering the entire body, auxiliary landing propellant tanks, the Mechazilla catch system hardware, advanced sensors monitoring every system, software managing thousands of variables. Every component adds mass. Every kilogram of structure is one less kilogram of propellant delivered. What if none of that hardware existed? An expendable Starship tanker strips everything unnecessary. No flaps because it's not returning through atmosphere. No heat shield because it's not surviving re-entry. No landing systems because there's no landing. The vehicle exists for one purpose: deliver maximum propellant and burn up on re-entry or drift away in space. Musk stated this directly. Max payload to standard Earth reference orbit is actually around 180 tons for Starship, when fully reusable, and approximately 300 tons if expendable. That's not theoretical. That's engineering reality. The expendable variant delivers 100 additional tons per flight. Applied to tanker missions, you're looking at 275 tons of propellant transferred instead of 175 tons. Does that difference actually matter? Run the numbers. The depot needs 1,500 tons total. At 275 tons per flight, you need 5 or 6 missions instead of 12. Mission risk drops by 50%. Half the launches means half the chances for catastrophic failure, half the launch windows needed, half the ground operations. The timeline compresses dramatically, but isn't throwing away entire starships wasteful? Not compared to the alternative. Building an expendable starship is radically simpler. Manufacturing skips the heat shield tile installation entirely. Those 18,000 tiles represent hundreds of labor hours per vehicle. Each tile gets individually fitted, bonded, inspected. The expendable variant eliminates that entire workflow. Production time drops, costs drop, complexity drops. SpaceX still recovers the super heavy booster. That's where the real money lives. 33 Raptor engines on the booster versus 6 on the ship. The booster represents roughly 70% of the hardware value. Catching and reusing boosters while expending ships creates a hybrid approach, not fully reusable, but dramatically more capable than current alternatives, and critically, it's achievable right now with existing technology. Think about what SpaceX sacrificed chasing full reusability from day one. Years of development focused on heat shields, flaps, landing systems, hundreds of millions in R&D. If they'd started with expendable starships, they'd already be delivering massive payloads to orbit regularly. The ISS wouldn't be the only game in town. Is there actually demand for that capability? The entire International Space Station weighs 420 tons. Think about that. Decades of assembly, 42 separate launches across multiple rockets, Russian Proton, American Space Shuttle, European Ariane, Japanese H-2. All that complexity to build one structure. An expendable starship could theoretically lift the major modules in just 2 flights. The Russian Zarya module weighs 19.3 tons. Zvezda is 19 tons. US, European, and Japanese modules run 15 to 18 tons each. Starship's cargo bay measures roughly 8 meters in diameter with 18 to 22 meters of usable length. Those ISS modules would fit. Multiple modules per flight. Not just the structure, but solar panels, trusses, supplies, everything needed. A single flight could carry 10 to 12 major modules theoretically. Practically, you'd fly conservatively with 6 to 8 modules to ensure proper securing and center of gravity balance. But the capability exists. Vast Space already sees this potential. They signed with SpaceX to launch Haven 2, the most advanced commercial space station planned. The core module measures 7 meters in diameter. Only Starship has the volume and lift capacity to put it in orbit efficiently. 4 secondary modules at 3.8 meters diameter will fly on Falcon Heavy with extended fairings. Launches start in 2028, full station completion by 2032. This isn't science fiction. Contracts are signed, hardware is being built. But here's the irony. Despite this incredible capability, expendable starships wouldn't fly often. Falcon Heavy faces the same problem. When you're paying for an entire rocket, customers want maximum utilization. Every kilogram matters. You wait until you have enough payload to justify the cost. But with a fully reusable system, the economics flip. You're essentially paying for fuel and operations. Smaller payloads launched more frequently make economic sense. The expendable variant serves a specific niche. Missions requiring absolute maximum capability where reusability doesn't matter. Lunar refueling is that exact mission. Speed matters more than cost. Reducing risk matters more than recovering hardware. Getting astronauts to the moon before competitors matters more than perfecting reusability. The expendable tanker solves the immediate problem while SpaceX continues developing the ultimate reusable system in parallel. And this strategy extends beyond the moon. Mars missions require even more propellant in orbit. The distances are brutal. Launch windows open every 26 months. Miss your window, you wait over 2 years for the next one. Expendable tankers could stockpile hundreds of tons of propellant in depots, ready when the Mars transfer window opens. The first crewed Mars mission won't wait for perfect reusability. It'll use whatever works. China isn't waiting either. Their Long March 9 super heavy lift rocket targets similar capabilities. Their lunar program has clear timelines. The race is real. SpaceX holds the technical lead right now, but leads evaporate quickly in aerospace. The expendable Starship variant represents SpaceX's ace card. Deploy it, secure the moon landing, prove the capability, then perfect reusability for sustained operations. Two-phase approach, maximum pragmatism. So here's what this really means. SpaceX isn't abandoning reusability. They're choosing victory over perfection. The expendable Starship variant is a tactical move in a strategic game where timing decides everything. While engineers continue solving the heat shield puzzle, these stripped-down tankers start flying. Propellant accumulates in orbit. NASA's timeline stays on track. American boots touch lunar soil before any competitor arrives. That's the goal. That's what matters right now. And speaking of what's happening right now, yesterday brought something special. American astronaut Chris Williams launched aboard Soyuz MS-28 on Thanksgiving morning. 3 hours later, he docked at the ISS. His uncle said Chris used to play basketball with cousins on Thanksgiving. Now he's orbiting Earth at 17,500 miles per hour. The crew celebrated with turkey, mashed potatoes, cranberry sauce, even lobster. 7 people sharing a meal 250 miles above the planet. Chris will spend 8 months up there testing European gym equipment, growing semiconductor crystals, and helping develop safer landing procedures. Meanwhile, Russia's Soyuz 5 rocket just arrived at Baikonur after nearly a decade of development. First flight scheduled before year's end. 18 tons to low Earth orbit, powered by the RD-171MV engine. Even competitors keep pushing forward. The space race never really ended. It just evolved. What do you think? Does the expendable Starship approach make sense, or should SpaceX focus purely on reusability? Drop your thoughts below. If this breakdown helped you understand what's really happening, hit that like button and subscribe to New Space Review for more analysis that cuts through the hype. Share this with anyone following the new space race. Thanks for watching.